So question number 11 is a fairly advanced calculus question. It starts with a differential equation, dx dt equals 10 e to the negative t over 4 minus x over t plus 1. And it wants us to show that t plus 1 is what they call an integrating factor for this differential equation. So the integrating factor was u of t in what we called a first order linear differential equation, or FOLDE. So basically, to make that work, we need to bring this part over, separate the x from p of t, and q of t is what's left on its own. The integrating factor then is e to the integral of p of t dt, or it's e to the 1 over t plus 1 integrated, which is the natural log of t plus 1. E and natural log cancel, and you're left with just t plus 1 as u of t, or what they refer to as the integrating factor. Part B of the question says, using that, solve to get to the solution they gave us. So, the solution to a first order linear differential equation is x equals 1 over u of t, q of t, dt. Now, q of t had a 10 in it, so I pulled that 10 to the front. 1 over u to the t, or u of t, turned into 10 over t plus 1. The integral of t plus 1 e to the negative t over 4. This is now two different kinds of functions. This becomes an integration by parts, and really that's what makes this a more advanced problem. It's not only a first order, but it's also an integration by parts. So this thing is just going to sit in the front until we're ready for it. Integrating by parts, we have algebra and we have exponential. So algebra is u, du is then just dt. Integrating that is a u sub with negative t over 4 is u. That means we need negative 1/4, so negative 4 comes out to the front, and then it's just e to the u, so v is negative 4e to the negative t over 4. Integration by parts starts with u times v, so it's negative 4 e to the negative t over 4 and t plus 1 minus the integral of v du, so that's negative 4 e to the negative t over 4 and then dt. This stuff I just left alone. This now becomes plus 4. This integral we already know from back here, so it becomes minus 16 e to the negative t over 4 plus c, and we now have our integral. The problem is that doesn't look anything like the solution. So what I should notice first is that I can distribute this t plus 1. If I distribute this 10 over t plus 1, these t plus 1s are going to cancel, and you'll get negative 40 e to the negative t over 4. This t plus 1 just ends up in the bottom, and you get negative 160 e to the negative t over 4, and then plus c over t plus 1. Now I can find c because I know in the question that at time 0 there was nothing. So that means I can set 0 for x equal to 0 for t. Well, e to the 0 is 1 in each one of these cases. T plus 1 is 1. So that just gives me negative 40 minus 160 plus c. So c is 200. That now brings me to this equation. The first thing I do is get a common denominator that puts t plus 1 back in here and also on the bottom. So now these are all common denominator. These two both have e to the negative t over 4 and negative 40. So I factor that to the front. The 200 just stays. Negative 40 e to the negative t over 4 times t plus 1 plus what's left in here is 4, or t plus 5 is what we were trying to show. Part C of the question says sketch the graph. Well, that's where your calculator comes in. You're just going to draw the graph directly in the calculator. Just type this in the function. Now you'll have to call this y and you'll have to call this x to be able to graph it, but it gives you this function. The maximum can be found just by asking the calculator. You graph those out, and then you interpret your maximum, and that's part C. Part D of the question can be found in one of two ways. Either you can use this graph and ask the calculator for a point of inflection, which you can do under menu, under a graph. So if we go graph, menu, analyze graph, inflection point is an option. So you can ask the calculator to do it that way. Or you can go ahead and just graph this function that we started with. The problem is that has y in the middle of it. That's a little challenging to get to work. So it's probably easier to use the point of inflection from there. And if we do that, the calculator will just tell us that the answer is 12.9. Now for part E of the question, it says the rate of change of the amount of salt leaving the tank is equal to x over t plus 1. Find the amount of salt that left the tank. So I want to do the integral from 0 to 60 of x over t plus 1 dt. The problem is this is the wrong variable. So in place of x, I use the part from the previous problem, this piece, which is why they actually gave this to you to start with, because now you can use it at this point. So all you're going to do is plug that in as the integral, let the calculator integrate that for you because it can do an integral with known boundaries. It can do a definite integral, and it gives you 36.7 grams.